Hello students, welcome back to the class. Today we will start the class with the topic common ion effect. The definition for common ion effect is that a shift in the equilibrium on adding a substance that provides more of an ionic species already present in the dissociation equilibrium. So this means that whenever any reaction is occurring, you will get some ions, and that ions form equilibrium with the reactants. Now if you add extra ions which is already present in the solution or in the equilibrium equilibrium reaction, then what will happen? This will shift the equilibrium onto the backward direction. For example, let us take acetic acid, which dissociates as H positive and CH3COO negative. Okay, for convenience, CH3COO negative is designated as AC, that is your acetate ion here. So here this is CH3COO, so that is designated as AC, and H is there, so this is hydrogen present. Okay, and then equilibrium with hydrogen ion plus the species the anion itself. Okay, AC negative. You can write the first reaction also instead of the second. This is just a short form of the above reaction. CH3COO is the acetate ion, this is the acetic acid, this is the hydrogen or the proton, then CH3COO is the acetate ion. For equilibrium, Ka, this is the equilibrium constant, equal to the multiplication of the concentration of the products, and our products was H positive and AC negative. Okay, hydrogen ion and acetate ion. So we will take the product multiplication of the concentration of these products divided by concentration of the reactant, that is HAC. Now what are the ions that are present? H positive and AC negative acetate. Now in the equilibrium mixture, if we are going to add some extra acetate ions, then what will happen? According to Le Chatelier's principle, the increase of concentration of the acetate ion will occur. Since it was in equilibrium, now you have disturbed the equilibrium mixture by adding more amount of acetate ions, so this will try to decrease. If you are increasing the concentration, the equilibrium mixture will try to decrease the concentration. It will always act opposite, so that it always maintains the equilibrium condition. So since we have disturbed the equilibrium, the whole system will try to attain equilibrium again. And how it will attain? Since we have added extra, it will try to decrease that extra. Okay, so now, as you know, in an equilibrium reaction, forward reaction is also taking place and backward reaction is also taking place, right? So in order to increase acetate ion, this acetate ion has to react with the hydrogen ion and then form the acetic acid back. Then only acetate ions will decrease in the solution. Clear? Again, another way is that if you increase the hydrogen ion concentration, if you add extra hydrogen ion concentration in the reaction mixture, again it will try to decrease and maintain the equilibrium. And how it will decrease? If these two are reacting, then this will be forming. Okay, so acetate ion back it will form. Whenever any reaction is occurring, the reactants react together and it forms the product, right? In that case, the reactant concentration always decreases. If you are saying that A and B is reacting to give C, so when A and B is reacting to give C, in the course of time, A and B, the concentration of A and B will always decrease. Okay, and the concentration of the product will always increase. Clear? Now here I have written already, addition of the acetate ions in the solutions will decrease the hydrogen ion concentration. If you are increasing this, okay, this has to decrease. And how it will decrease? This with this it will react, right? With the hydrogen ion it has to react. Ultimately the hydrogen ion concentration will also decrease. Okay, and vice versa. And this is followed according to the Le Chatelier's principle, which we have discussed in the earlier classes. The definition again, let us see: a shift in the equilibrium on adding a substance that provides more of an ionic species already present in the dissociation equilibrium. Means there will be a shift in the equilibrium. There will be a change in the equilibrium on adding a substance that is already present. Okay, since we have taken the acetic acid as an example, and already acetate ion and hydrogen ion was there, it was maintaining equilibrium, but we have disturbed the equilibrium by adding more amount of acetate ion and or more amount of the hydrogen ion. So in that case, it will always try to shift in a direction that the equilibrium is maintained. Clear? Next, another topic is the buffer solution. The solutions which resist change in pH on dilution or with the addition of small amount of acids or alkali are called buffer solutions. Okay, you know that we can always determine the pH of a solution. Okay, the simple way is that if you don't want to go for the specific value or the certain value, then you can just say whether it is an acidic substance or an basic substance by using the pH paper. If you put the pH paper on any solution or any substance, or even with the food items, you can do that. You can test whether it is acidic or basic. Okay, if the blue color changes to red, then you know that it is acidic substance. Okay, and vice versa, or the opposite will happen for the basic substance. Clear? So that will happen with the pH paper or the litmus paper. Now you know that you can every substance is either acid, base or salt, right? And now some solutions are present. Okay, some chemical substances are present. If you mix them together and if you try to mix them in a certain proportion and create a certain pH, then that pH is maintained. Okay, that pH is maintained even if you add the acid or base up to a certain amount. Now let us first see the definition. It will be clear to you. Along with that, we will also discuss two examples. The solutions which resist change in pH. Okay, some solutions are there which will resist the change in pH. Whatever pH they are having, whatever pH we have made up to, that pH is maintained on dilution or with the addition of small amount of acids or alkalis. Even though if you add some amount of or tiny amount of acid or alkalis, you know that if we add acid to a substance, it will become acidic. If we add base, it will become basic or alkalis, you can say, right? So but some substances are there which if you add very small amount of acid or base, it is not going to change the pH. Okay, for example, acetic acid and sodium acetate. If you mix acetic acid and sodium acetate in such a way that the pH becomes 4.75. Okay, if you mix acetic acid and sodium acetate and make the pH 4.75, after that it will not try to change itself. Yeah, if you add more acids and like more basic, then it will change the pH, but if you add very small amount of them, then it is not going to change the pH. It will always try to maintain that 4.75 pH. Clear? Now second example is if you mix ammonium chloride and ammonium hydroxide and make the pH, okay, you have to mix in such a proportion, in the ratio has to be such that the pH is 9.25. okay, now 9.25, this is a basic substance. Okay, 4.75, this is an acidic substance. Remember, because you know that if it is less than 7, then it is acidic, and if it is more than 7, it is basic. Okay, so after this 9.25, it is not going to change the pH if you add only small amount of acid or base. Again the same thing, if you add more amount, much more amount of acid and base, then it is going to change the pH, no doubt. Okay, but for small amount of the addition of acid or base, it is not going to change the pH for 9.25. So we have two topics left for this chapter. I hope you have covered up all the classes for equilibrium, because this is a very lengthy chapter actually. Since it is going online, it is completed within few days, but otherwise it is a very lengthy topic for those who are studying. Okay, I hope you are done with the previous classes, and just one more class for tomorrow and we will be done with this chapter.